In this episode, you will learn how to make multiple sensors monitoring system using Reyax RYLR890 based LoRa module and Arduino. This is an advanced level project and explains how to split the entire string message and store the different parameters and different variables. With the help of this project, you can monitor multiple sensors within 15 km range. In this project, I have used 3 variable resistors as the sensors, which of course you can replace with any other sensors you want. As the sensors values are stored in different variables, now you can use F conditions to monitor each sensor individually, and then you can control some relays or you can send notification messages, etc. In today's episode, you will learn how to make Raspberry Pi based industrial automation system using Raspberry Pi 3B+, 5.5-inch OLED touchscreen, Wi-Fi keyboard and mouse. The HMI or GUI application is designed using the PYQT5 software, and the Python programming is done using the Thony IDE. This is part 1 of the Raspberry Pi industrial automation system, which only covers how to design an HMI application for the Raspberry Pi and control some relays. For the demonstration purposes, I have connected 220 volt AC bulbs. In today's episode, you will learn how to make an IoT weighing scale using HX711 24-bit analog to digital converter, a 5 kg load cell or strain gauge, Nodemcu ESP8266 Wi-Fi module, Arduino, and a cell phone application designed in Blynk. Later in this tutorial, I will explain why I'm using Arduino with the Nodemcu ESP8266 Wi-Fi module. With this DIY low-cost IoT weighing scale, you can measure and monitor weights from anywhere around the world. For the demonstration purposes, I'm using some known weights: 50 grams, 100 grams, 200 grams and 1 kg. This is my third video on the HX711 and load cell, which explains how to use the Wi-Fi technology to make an IoT based weighing scale. While in my previous 2 tutorials I explained the basics, like for example, what is HX711, soldering, interfacing, and the load cell or strain gauge calibration. I highly recommend you should watch my previous 2 tutorials and then you can resume from here, because this episode is entirely based on my previous 2 tutorials. I will modify the previous program, and I will also explain how to establish the serial communication between the Arduino and Nodemcu ESP8266 Wi-Fi module, and then how to display the weight information on the 16:2 LCD widget. In today's episode, you will learn how to make a home or office automation system using Raspberry Pi 3B+, MFRC522 RFID reader, 5.5-inch OLED, HDMI touchscreen, RFID tags, and a 3-channel relay module. For the demonstration purposes, I have connected 220 volt AC light bulbs, which of course you can replace with any other electrical loads which you want to control using the RFID tags. The whole system works perfectly. There is no false triggering, and the load status is displayed on the 5.5-inch OLED capacitive touchscreen. The Raspberry Pi programming is done using the Thony IDE. This project can be easily modified. More relays can be connected, which can be used to control the DC loads as well. This way you can make a smart home or office automation system. Today's episode is entirely based on my previous tutorial, which covers the extreme basics, like for example, how to activate the SPI, how to download and install different packages for the MFRC522 RFID module how to write some basic Python scripts for reading the text. I highly recommend you should definitely watch my previous tutorial. You can find link in the description. While everything is powered up, never touch the backside of the relay module as 220 volt AC can be really dangerous. I recommend you should wear protective gloves. The Internet of Things based fridge or smart IoT refrigerators are becoming very popular because with the help of a smart IoT refrigerator, you can check the temperature, food items, expiry date, door opening and closing status from anywhere around the world using the Wi-Fi technology. In this episode, you will learn how to convert any fridge or refrigerator into a smart Internet of Things based fridge or refrigerator using a push button or a limit switch, Nodemcu ESP826655 module, a variable resistor, DS18B20 one-wire waterproof digital temperature sensor capable of measuring the temperature from -55°C to 125 centigrade, and a cell phone application designed in Blynk. The values are updated every second. The notification messages are sent to the owner each time the temperature increases above or decreases below a certain predefined value, which can be adjusted using a variable resistor. Any value between -40 and +40 can be selected. This limit is specified in the programming, which can be changed as per the requirement. A push button or a limit switch can be used with a fridge or a refrigerator to check if the fridge door is opened or closed. If the door remains open for 3 minutes, a notification message is sent to the owner. The 3 minutes delay can be increased or decreased as per the requirement. The notification messages are sent even if the application is running in the background. If in case due to some problem the Wi-Fi connection is disconnected, a notification message is sent to the owner or supervisor. This project can be easily modified by adding more sensors and some relays for controlling the fridge or refrigerator. In this episode we will cover number 1, DS18B20 introduction, number 2, complete circuit diagram, number 3, interfacing, number 4, Blynk application designing, and finally number 5, testing. In today's episode you will learn how to control electrical loads using 10.1-inch HMI TFT LCD display module and Arduino. The control commands are sent serially from the HMI touchscreen display module through the MAX 232 board to the Arduino. The Arduino then turn on and turn off the desired load depending on the command. Using the same button, you can turn on and turn off the load. For the demonstration purposes, I have connected 220 volt AC light bulbs, which you can replace with other AC or DC loads. Be very careful while working on the 220 volt AC as it can be really dangerous. Wear protective gloves. This project is entirely based on my previous 3 tutorials. In tutorial number 1, I explained how to design a graphical user interface using the images designed in Adobe Photoshop, how to use the button function, data variable function, hardware parameter function, and how to use the drag, adjustment and slider scale functions for controlling the screen brightness. While in tutorial number 2, I explained the commands used for reading and writing, how to control the user interface without pressing the on-screen buttons, how to access the brightness control register, and so on. In tutorial number 3, I explained how to monitor a sensor in real time using Arduino and the HMI touchscreen TFT LCD display module. So I highly recommend first watch my previous tutorials and then you can resume from here. In this project I'm using the same GUI but with a little modification. This time I added the control button on the main screen image and also added the control panel images designed in Adobe Photoshop. In this episode, we will cover number 1, complete circuit diagram, number 2, Arduino interfacing with the HMI TFT LCD module, and number 3, Arduino programming. In today's episode, you will learn how to make an IoT Internet of Things based notice board using Nodemcu ESP826655 module, Max7219.matrix 8x8 LED modules, and Blynk application. The scrolling text message on the 8x8 LED matrix can be updated at any time from anywhere around the world using the Blynk application. The scrolling speed of the text message can be controlled using a variable resistor or potentiometer. This is version 3 of the 8x8 scrolling message, which is entirely based on my previous 2 tutorials. Version 1 is based on the computer-controlled scrolling text, while version 2 is based on the Bluetooth-controlled 8x8 LED matrix scrolling text display system. So I highly recommend first watch my previous 2 tutorials and then you can resume from here. There are situations when you need to play a specific recorded voice message depending on the situation. Like for example, in case if someone end up in a car accident, when a sensor detects a strong hit, a pre-recorded voice message is played endlessly.
Please help me, anybody there? Please help me, anybody there? Please help me, anybody there?
The IST1820 voice recorder and playback module can also be used in security-based projects. When an intruder is detected, a voice message is played endlessly.
Intruder detected. Intruder detected. Intruder detected. Intruder detected.
The IST1820 module can be used in offices where you need to play different voice messages. For example, when someone opens the door, a welcome message is played only one time.
Welcome to Electronic Clinic. Welcome to Electronic Clinic.
If it's a break time, you can record a new message. Now this time, if someone opens the door, the break time voice message will be played. Break time, please come back after 30 minutes.
Break time, please come back after 30 minutes. Break time, please come back after 30 minutes.
You can record different messages depending on the situation. In this episode, you will learn how to interface the IST1820 voice recorder and playback module with Arduino, how to manually and automatically play different voice messages using different types of sensors. Every year more people die from unsafe water than from all forms of violence, including war. Have you ever tried to find out what is the pH value and TDS value of the water you are drinking? Using a pH sensor and a TDS sensor, you can make a perfect water quality monitoring system. I have already used the pH sensor with Arduino and Nodemcu ESP826655 module for measuring the water quality. You can find links in the description. In today's episode, you will learn how to make a water quality monitoring system using the Gravity TDS meter V1.0, DS18B20 waterproof 1-wire digital temperature sensor, and 16x2 LCD with Arduino for measuring the TDS value. TDS stands for Total Dissolved Solids. The TDS value, as you can see on the LCD screen, indicates how many milligrams of soluble solids are dissolved in 1 liter of water. Many TDS meters display the TDS value in ppm, which stands for parts per million. In general, the higher the TDS value, the more soluble solids are dissolved in water, and the less clean the water is. Right now the water under test is excellent as the TDS value is less than 300. The TDS value starts increasing as I start adding the salt. So using this small DIY low-cost TDS meter, you can find out if the water you are drinking is clean or not. Along with the TDS value, you can also see the EC and temperature values, which I will explain in a minute. I will also explain what TDS value is good for drinking water. I will explain all the 3 parameters in detail. You can also use a TDS pen, which is quite cheap and can be used for measuring the TDS value. But if you are planning to make a hydroponic system which maintains a certain pH level, then the TDS pen will never work, because for hydroponic systems you will need an automatic system which can turn on and turn off other electrical devices. Moreover, you cannot use this TDS pen in IoT based projects. But this TDS meter by the DF robot can be used in automatic hydroponic and IoT based water quality monitoring systems. In today's episode, you will learn how to make a word clock using a 10.1-inch HMI TFT LCD display module by the Stone Technologies and a Nodemcu ESP826655 module by the Espressif Systems. This is the smartest word clock. You don't have to enter the hours, minutes and seconds manually, and there is also no need to use the RTC real-time clock module. All you need is simply select a time zone on your cell phone application designed in Blynk, wait for a minute, and the time will be updated. This is the Pakistan's standard time. These are the hours, these are the minutes and seconds. The time is synchronized with the server timing after every 1 minute, due to which you will always get the exact time. If due to some issues the Wi-Fi is disconnected, the word clock won't stop working. The minutes and seconds are incremented automatically and will continue to work. When the Wi-Fi connection becomes active, the word clock is synchronized again with the server time. Let's select a different time zone. I'm going to select New York, America. As you can see, the time is updated and now I can keep track of all my favorite TV shows and movies from Pakistan. Now let's check time in Sydney, Australia. This work log is based on the 24 hours time format, due to which we can easily know if it's the daytime or night time.